The broadcast is now starting. All attendees are in listen-only mode.
Hello, folks. If you can hear me, raise your hand, folks. Wonderful. All right. So now, this is our final official webinar, but I will have a webinar Monday night for questions and things. So I'll come up and we'll have it for, probably less than 30 minutes, but we'll have a webinar then as well. So I'll put everybody's hands down. If you would, please start up Tinkercad and then go to Tinker Circuit. We want to make this right here. So we want to go ahead and let's bring this up. So you want to bring out an Uno. You want to bring out, there's a ground, there's a power. Power to here, goes to that, to the switch. 10K resistor. Make sure you realize it's a 10K resistor. Wire, let me go back. Sometimes easier with wires. It's 10K, make sure it's that. And this is what's called a pull-down resistor in a minute. So, here's what I need you to do, folks. As you're building that, raise your hands once you have it built, and then we're going to go through and code it. We're going to do a digital read, and then we're going to do an analog read. And then we can tie this back in, and we'll do an analog, but I will also hook this up to an LED so you can see how you would control this if you wanted to, if time permits on that. So let's go ahead and do this. Remember, too, if you don't have access and you're not going to be able to do the simulation, just raise your hand so we're not waiting on you when you'll never get it done. Let me see the questions here. All right, let me go up. I'm going to pull this up a little bit. All right, we got one done. Let's get everybody else. Take a few moments. Not a super rush. We got started right on time, so we're good. All right, give it just a few more moments and we're going to get started explaining the code to this. Okay, now I'm not seeing any questions right now for a minute because I'm running this. I'll get a moment, I'll answer questions. So this is a comment. This is for text. As you can see, it's a title block. You want to use that. And then you can put comments all around there. So the title block is to tell you what it is. Here's a comment. Read the input pin. Set button state to read digital pin 2. There's pin 2. It's going up and it's reading this. Now, then say print to serial monitor with new line. Now all that means is skip a line every time down. So this is giving us a value. Right now, nothing's going on. All I'm getting is a value of 0. Make sure you click on serial monitor. So all we're trying to do is read the state of this. Is it 0 or 1? And we're going to explain this in a moment. So if you'd be so kind, add this code in here, just like we have it on there. So I'll put everybody's hands down. Raise your hand when you have this built and the code. Remember, it's over here to get these different comments you saw in the grade. Variable as set button state to, well, read digital pin. And the input, that's output. So input is right there, read digital pin 2. There's analog, they are different. Read the degrees of servo on pin so, number of serial characters available, read from serial, read ultrasonic distance on trigger, read temperature. So they're giving more and more of these to help with that. And then there's clearly the math. Here's variable states. You can also create a variable, which is a nice change. And then there's functions. You can count up and down. Okay, let's see how we're doing on the code and setup, see how we're going. I think we're doing, we still got some more time. So let me give people more time to do this. Raise your hand if you're not going to do it, so we're not waiting on you. But again, these are comments. You find them in notation block. Just gives you just the title. And then this one is digital read. Digital read serial output, really. Comment, read the input pin. Set button state. We've got that over here. Set button state to, and what you're saying is, hey, are you going to read this? Let's go get input, read digital pin. In this case, it's 2, and that's what's hooked up there. Then comment, print out the state of the button. Print to, this is another output. Print to cellular monitor instead of hello world, button state. Okay? Okay, I've got enough now that we're going to go ahead and proceed. So if I can get everybody's attention, you can come back to this later. This video will be recorded. You can see it here. But again, let's look at this. We got 5 volts going into here, running this wire to this button right here. Then going back, ground to that resistor, 10K, here to ground. That's what it's doing until, watch when I press the button. Let's make sure, let's run it. Now, when I press this button, watch what happens. See? It's when I press, it's 0 unless I press the button. When I press the button, it's 1. Here's what's happening. When I'm running the simulation and I press this button, it now connects to this side as well. So this power can go one of 2 places, back here or here. But because I put a really 10K resistor, very high resistance, it much prefers going this way, so I get the full signal to button 2. If not, when I press this button, it could either go here, and if this is directly hooked to the ground, well, it could go to the ground or it could go to pin 2. We don't want that. We want it all going to pin 2, called a pull-down resistor. And that's why when I run the simulation and I press the button, the value on the serial monitor. A serial monitor is really good, very good for telling us what's going on. That way you can sit there when you program, there's not a problem, you know. And so you can also do this too. You can say button state, you can do a math variable here. All right. Let's do this. All right, you can pick a random number there. We'll go here. We'll do that. Button state. And what you can say is equals 1. If that's the case, light up an LED. So let's pretend we had an LED hooked to 9. I want you to go to 9. Kind of pulled that's not great. I'm going to put it right there. All right. And in fact, you know what? I'm going to do something. I'm going to delete that and do it a little bit better. We go 9. Everybody can do this, please. Here. Here. All right. Then I'm going to take a resistor, or excuse me, let's get rid of code there. Let's go all our components, basic components, get an LED there. We're going to take the long leg of the LED and put it on the pin. See how the long leg's connected right here? And then, maybe so you can see it better, I'll move this up. All right, on the negative leg of this, I'm going to run another resistor. This time the resistor isn't going to be 10,000, it's only going to be 300. So I'm going to go here, I'm going to go to ohms, I'm going to do 300. Now I'm going to start my simulation. Let's look at code. Right there's my serial monitor when I press the button. All right, so what's going on? I'm not getting power. Oh, wow, you clicked it on there, but you don't have any power. Why? I was shocked. It didn't work because I don't have any code to tell it so. So if I stop the simulation, now I got to go to output. So I'm going to set pin 9. I'm hoping you guess which pin that is, or pin 8 actually in this case. Set it to high. All right, now let's try it. So that's, remember, you can have it physically hooked up, but you got to talk to the software. Let's try it now. There it is. Now, if you notice, all right, let me ask some questions. Think about why it's always on right now, and then we're going to talk about. Do we have any questions? Let me go ahead and do this. Mine says an error. What? I'm not sure what the error is. You got to give me a little more details. Sorry. Anybody else have any questions? Let me go attend the eggs. All right, let's drop it down. You can also raise your hand on there if you have a question. I'm going to go look at it. Okay, once we do it, now if I stop the simulation, run it again, the LED's off. The minute I press that button, it's on there. If everybody understands what I've just done that, can you please, if you'd be so kind, and I won't show you until you do it, get it so if I'm not pressing that button, that LED's off. But if I press the button, it is on. Hint, look at the controls. Well, you could ask. Give me a few minutes here, folks. All right, now, like anything, let me know. Raise your hand once you've added that. You've got it, so, all right, that'll way to jump on it. All right. You guys are crushing it tonight. Well done. Okay. All right. So now here's what we're going to do. I'm going to go over here. I'm going to take a new bit of code here. I wish it let me. It's kind of a pain. All right, I'm going to pull this code off. I'm going to make a duplicate here. I'm using if then else statement. So I'm going to pull this stuff off my if. So that's just like before. And if I ran it, I don't know if it'll let me run it or not. Oh, sorry, code errors. It won't let me do that. I got to tell what the S is. Okay, great. All right, so let's get rid of that. So here's the else. And I think you guys are going to guess this. We're going to go to output. We're going to set pin 8 to low. Now let's start the simulation. All right, now let's look up code because it's always good. Good serial monitor. We're getting zeros. I want to hit this. It's 1. When I let go of it, the light goes away. See that? So, anytime you press the button, light goes on. When you don't, it's off. Surely we have some questions by now. Besides someone saying earlier there's an error, I don't see anything else. Anybody else have a question? I'm putting his hands down. Raise your hand if you want to ask it. All right. So I'm going to save this. I'm going to not save it as. They've improved this now, so it does this. All right, I'm going to make button control LDD. All right. All right, still don't see any questions, so we're going to. Mine is reversed. I'm not sure what that means. Oh, okay. Oh, someone got some questions. Excellent. Let's see if I can get to this. Can you use the switch in the same way with the same basic code? Let me see. Okay, mine is reversed. Let me see what's going on. Mine says an error. I'm not sure what that was. Mine is reversed. Julie's saying, goes on when I hit the button. That's what it's supposed to do. Could you switch? Can you switch the code in the same way with the same base? Could you use a switch? Yeah, that is a switch. Just to call the momentary switch. On all times. Oh, it's on all times and goes off. Well, my guess is one of two things. I'm glad you told me that, Julie. No worries. All right, here. Julie, when you do that, let's go through the hardware. Let's start with the hardware. First, maybe it's easier to do the software real quick. Maybe you have your button state wrong. But set button state to digital pin 2. Make sure that's 2. Read it. Print to serial monitor button state. By the way, does this button state say 0 all the time or 1 all the time? You press it, it goes to 0? I'd be curious on that. Make sure you have the right pins. Over here, do you have the ground on this black line connecting to the first pin on the switch? Is the switch across like this? Does the 10K resistor go down the other leg of the terminal, terminal 2B? This is 1B, 2B, 1A, 2A. So, let's just go through this. Ground to the 10K resistor to terminal 2B. On the other side of that is the line that goes all the way back to 2. The input all the way to 2. As far as power goes, that's 5 volt here to the terminal right there. Did that help? Julie, did that fix it for you? Great. Someone used the slide switch and made it work. Yes, good job. Well done. All right. Okay, Julie, I don't know what to tell you because computers all work consistently the same. I'd be curious about how this button is set up. I'd make sure our ground, I'm wondering about this ground. I'm still kind of concerned about that. And obviously, if you wrote over here, when you run this, click the button and see if you're getting zeros or ones. Because it's saying if it's equal to 1, set pin to 8 to high. If it's equal, if else, it's always low. So, do you have that at 1? What's the resistor at? This resistor's at 10K. The resistor next to LED is at 300. Yes, it does matter where switch is to control the LED. Well, as long as it's set up this way, it can be anywhere in the breadboard. Let me state it that way. Julie says, bubble. What does that mean? Sorry, Julie, I'm not sure. Zeros before I hit button, then when it goes 1 when I hit it. That's what you keep going. Try again later. All right, thank you, Julie. Watch us in the video. We'll get there. All right, now I'm stopping the simulation. I've done that. I'm going to go back to Tinkercad. This is how I practice a lot of stuff. I'm going back into circuits. I'm going to create a new circuit. I go out to Arduino, basic Arduino. In this case, we're going to do an analog read. Let's bring it out here. So everybody go to analog read serial. And you can see already by now, I hope you're seeing that. It can be a software issue, it can be a hardware issue. Then I'm going to go to basic components. I'm going to select the breadboard, small breadboard, out here. Okay. Now, the middle one, so we remember, is going to be hooked to A0. Left is red, 5 volt, and the ground is on the right side. Okay? So that one's going to be red, outside, right is ground, this is signal. So what I'm doing is hook it up just like this. I'm going to move this over somewhat so it's easier. This is just so I could visually see it. So I think we said red. Let's go this way first. Let's go analog. That one's going to be in the middle. We're going to make that, all right? We're going to make that yellow. That's just going to tell me I'm reading things. See how that goes there? Then we're going to take ground. Come over to here. We're going to make that black. And then we're going to take 5 volts. Go to here. And then it's going to take red. So there you go. Red, black, signal. Now, let's start the simulation on this. There's obviously code. Let's see if I see serial monitor. All right, show 0. Simulation's going. Let's see if we get any values. See how I'm getting values? All the way up to 1023. Can I get everybody? If you want to do it that way, go ahead. We can look at the code. Why don't we get everybody hooked up here first, and then I'll go through the code with you. As before, put everybody's hands down. When you get at least the hardware in there, let me know. Raise your hand. Okay, great. I'm starting to wonder. Excellent. Give everybody again. If you're not doing this, you don't plan on doing it, then raise your hand so we don't wait for somebody that's not going to do it. This is going to be very similar to what we just did. We're going to call it. All right. So remember, analog, digital's on or off, live or dead. Analog is a range, temperature, how dark it is. That's a range. Okay, so in the last time we did set sensor value to read analog A0. Then print serial monitor sensor value. So take whatever you're reading off this pin A0, assign it to a variable called sensor value, and print it using serial monitor. That's it as with a new line, which causes it to go down. If you didn't, it would just go horizontally. If you want to experiment at home with that, go ahead. So when I run the simulation, you can see those analog values. So go ahead and do that. I'll wait for you a moment on that. I'm going to go look at this. So I'm going to call this analog serial read. Then create a new circuit. We might just duplicate the other one, but I think it's easier to go here, Arduino again. They have pixel LCDs. It's to me analog in, serial out, smoothing, which don't worry, we're not really going to do that. Then they have some that allow you to read the analog values, and they keep adding more and more of these. So let's make it. I'm going to make. Go ahead and make another one. Basically, folks, let's do a lot of what we just did. Do Arduino. Honestly, I'm just going to do another analog read serial out again. We could do servo as well. And in fact, we can control the servo. So let's do analog read, and then we'll play with it maybe a little bit later with the servo. In fact, let's do this. Let's bring the servo in. All right. Servo's running. Let me look at the code here. Yeah, that's it. We're going to, let's hold off on the servo. Go back. Pardon me. Didn't mean quite to do what I just did. Sorry about that, guys. Tinker this. Let me get rid of servo on this. I was about to do something, but I'm worried I'm going to complicate matters. Delete. Yep, delete. That's all we care about. We'll get to this if time permits. So go ahead, go back to this. Just take a breadboard. Whoops. Go to basic, breadboard. I'm just going to bring this up here. I'm going to do everything I just did a minute ago. Delete that. I'm going to stick this up like this. It's good practice. Just go ahead. Remember the outside pin, first pin, we're going to do analog read. That was in the middle. Then the ground. It's all the way to the right. Make that black. Again, the color is just there to help us understand what we're doing. And 5 volts. It's to the left. We run the simulation. Code. We have the serial monitor. Click on serial monitor. And you can see that the value goes to 1023. And so, all right. Here's what can happen. Map to range, constrained to range. So this allows you to pick a value and convert it over. Remember that servo goes to 180? Or for example, an LED goes to 255, 0 to 255. So what you can do on this, all right, is we can do an output. All right, and what we're going to do is, we can say the set pin. All right, let's rotate servo, play pin, set pin to high, low, set pin to 3, right? Or drop that in there. And if you would, please connect an LED to pin 3. Again, that's going to be a basic. So I'm going to go back over. Let me close code so we can start playing with this. Basic. I'll just pull a resistor over here. We're going to make that again 330. Again, now we're going to do the same kind of thing, only this we're going to connect it analog. But if we connect it analog, that means we should be able to change it and not blow up. So there's 300. To that, we go over here. Let's go over basic. That's what we generally find. There's an LED. That's connected to the. Notice I'm putting the LED on the positive this time. It can just, it doesn't matter. Positive ground. We're going to go to ground with this one. Doesn't matter where you put the resistor on those two. Now, we don't want to, we could do that. Here's what I'd rather do on this. I'm going to move that, you could do it that way, but you know what makes more sense? Let's move this over here. Whoops. Move the resistor over here. It's on the short leg, so there's the ground. Click on this. Move it up here. I'm just going to delete that. It's faster this way. Click here. Click here. We're going to come right there. Make this yellow. Now, if we run this program, all we've done is set up the hardware. Long leg goes to the positive, this 3, and this is PWM capable, that little dash. Remember, that's a pulse width modulation. It turns on the frequency, a cycle of a computer. A computer runs at 60. They have cycles on a computer. And what it does is, so think of it just a time when the power is full power and then no power, full power kind of thing, right? Well, if you only had this LED on some of that cycle, it gives the appearance of fading. All right? We can go into a lot more detail on that, but right now I'm at the trying to get this knocked out for us today. It's almost quarter till as it is. So just trust me on this. PWM, here's 3. It's coming over here to this LED. I watch the simulation and I look at my code. My serial monitor is working. All right. Now, here's what we could do. So that's my sensor value. So what I'm going to do at set, I'm going to stop the simulation. Instead of setting that to 3, I'm going to go in variable. I'm going to put sensor value there. All right, let's start the simulation. It's at 41. It's fully charged there. Let me make sure. I would expect this to... Resistance 300. That's... where's... Oh, I know why. Stop the simulation. Mr. Dubik race through this. Let me hide code. We need to get that ground connected. So we're going to go right here where the ground is. So it's got a ground there, right? Let's take another ground. You can do 2 grounds that way. It's never a problem. Or we could overlap the ground. So I'm going to put a ground there. Make that black. It's in this other ground on this. There's lots of ways to do this. And then I'm going to ground here. Make that black. So I'm using 2 grounds in this. No real big deal. Let's go ahead and start the simulation. And there's the light. Now look at the code. See that? All the way. Only when I get really low to see how it goes dim. But once you get up to this level, it's staying the same the whole time, and then all of a sudden it starts to dim. All right. So you can see I can use that to either make the light brighter or dimmer. And we can... So I just did that. If everybody will set theirs up that way, and then we'll use something called a map value to help with that and make it better. Let me see people's questions. I'm sorry, I've got... All right. Because I can't have it up there, a lot of times I'm stuck. I don't see your questions. If you've got a question, tell you what, attendees, go ahead and get this. I'm putting your hands down. When you have this working, where I can adjust this potentiometer and the LED is dimmer or bright. See, right in that range there. Not surprisingly, it happens right when I get up to 255, it's bright. When I lower it down, not so much. All right, only one person's got their hand raised that they're done at this point, so I will wait till you're set there, and then we're going to look at some other things. See if you got that at this point. We may just get to here tonight. It's already getting up there. I'll show you map. We'll start mapping maybe Monday because it's not absolutely crucial, you know it, but if you want to see it. Just playing with all the different things they keep adding to it. It's been very impressive. So again, some folks, let me see if there's any questions. Oh, I was just set 10, no to 300. Okay. Good. Good job, Patrick. Let's talk a little bit about the contest again. Well, once you're done, let me give a few minutes. I want to talk a little bit about the contest coming up. Okay, folks, let's go ahead and do this, and then let's talk about the competition, just in case anybody's joined us after these webinars before. And now I'll leave the code out. Let me get maybe that'll make it a little bit easier to read without all that code up there. And I'm blowing it up a little bit. All right. So print to serial monitor, we have that. Set pin to sensor value, and that's why. But once it gets over 250, it's bright. Just kind of everybody knows that. We'll show you something called map down the road, but we can do that Monday. But let's talk about the competition because we have a few minutes now. Let me just say again, the competition is going to have two parts. First part, you're going to sit and troubleshoot it. It's going to go through it. We're going to tell you, hey, this should be happening, but it's not. Is it a software problem? Is it a hardware problem? Is it a both problem? You have to make a decision. Then the other half will be make a stoplight, or I'm just making stuff up. Make a professional motion machine, which, by the way, you can't do that. So that way, you get an opportunity to make the code. We will provide all the Tinkercad circuits and all the emails and all that good stuff. So you don't have to worry about that. All right? Any questions about the, you only use block codes. You can't use text code. That kept coming up last time. So let me go through questions here. Anybody have any questions about the competition? Oh. Oh, good. I'm glad someone found these useful. Good. Will it be using variables in the test? Sure. Yes. How long do we about half and half? All right, I'll repeat one more time. Half of it will be troubleshooting. I will ask you, say there's a problem, you pick the solution. It could be a hardware solution, software solution, or both. The other half is we're going to have you making simple circuits using with Arduinos. Okay, is there any other question tonight? I'm probably, before I go on to say something else that we would not necessarily get through tonight, and I don't want to confuse people. That's the worst of all worlds. So I'll stay on for a few more minutes for anybody who has a question, and some are still asking them, but we're, as far as common material, done. Will the Arduino examples be available during the Tinkercad build test? No. Any other questions? I'll hang on here. All right, what's this? How many approximately questions? Enough time to do them. I don't want to get into that level of detail because we may modify the test as the thing goes on in the spring. In fact, I guarantee you they're different tests. Any other questions? I'm going to miss the practice preliminary comments. Is there a way I can get the test so I can practice? No. You may not. I have a limited number of those. I appreciate that. I understand, but no, we have a limited number. So is there going to be a webinar Monday? Yes, a short one, just to go over questions. I may go ahead and, but that's what we'll do. Best way I think to practice would be to have someone set up a circuit, make sure it doesn't work, and you try to figure out why not. Practice building things. Take something like this and control an LED. Take something like that. Can you control a motor? Just keep playing with it. Thank you for doing these webinars. Happy to do them. Glad you like them. Well, folks, it's nearly 8:55. It's time for me to leave from school. I'm going to head on home. I'll start processing this video before I leave, but it'll probably get posted tomorrow when I come back to school. Okay? You all have a great evening. I know you'll do fine in there. Oh, you're welcome. Yes, Tuesday webinars posted. Get on the list and you'll always get it. All right? Okay, everybody. You all take care. All right? All right. Bye-bye. Take care, all.